let's take a look at number 2. An airplane's flying at an elevation of 6 miles on a flight path that is directly over a radar tracking station. So we've got the ground here. Here's our radar tracking station and our airplane. Alright, so it's going to fly over that tracking station. I practice every night. Alright, the airplane is an elevation of 6 miles. Let D represent the distance measured in miles between the radar station and the plane. So that's going to be this distance right here. If D is decreasing at a rate of 400 miles an hour, so that means dd dt, the change in D with respect to time, is negative 400 miles an hour. Right? Since it's decreasing, the rate has to be negative. When D is 10 miles, what's the velocity of the plane? So we're trying to find the velocity. Well, if we look at this, D is the hypotenuse of our right triangle. Right? The height over here, we'll say that's y, is 6 miles. And we have x down here. So we have D is 10, y is 6. What would x be? 8, right? Pythagorean triple, again, 3, 4, 5 triangle. We could figure it out. 6 squared plus x squared equals 10 squared and solve that, but if you notice, you can save yourself some work. That's just a 3, 4, 5 triangle. Now we need to look at the rates of each of those. So dd dt, that was given to us. It's negative 400. dy dt, what's the change in y with respect to time? 0, right? It's not changing. The plane's not a roller coaster. It's not going up and down. It's going to keep that same elevation. So dy dt is 0 for this one. And dx dt, the question asks us to find velocity, but that's what dx dt is. Right? That's actually our velocity. If you think about our picture here, the change in x with respect to time, that change in distance over time is going to be the velocity of the plane. Right? So we're trying to find dx dt. So this is another Pythagorean theorem one. You'll definitely see one with Pythagorean theorem on the quiz Friday. So we have x squared plus y squared equals in this case, d squared. So we're going to take the derivative of both sides. So we get 2x dx dt plus 2y dy dt equals 2d dt dt. So we can substitute those values in now to figure out our dx dt. We have 2 times 8 times dx dt plus 2 times 6 times 0 equals 2 times 10 times negative 400. So we get 16 dx dt equals negative 8,000. So if we divide both sides by 16, dx dt is negative 500 miles per hour. Again, the negative is just telling us that x is getting smaller. That variable, that distance between, that horizontal distance between the plane and the station is getting smaller.